Hey Math 20-3 and welcome to chapter 2. We're going to be getting into just graphing now. So making graphs, reading graphs. And yeah, that's pretty much it. So first off, 2.1, broken line graphs. So broken line graphs, to give you a heads up what I mean by that. It's going to be something like this, right? So if I just zoom in here a little bit, I was going to show you. So for something like snowfall, what it allows us to do is actually just connect the dots. So when you think like broken line graph, think of like a connecting the dots type of a graph. And that's a little bit different than a graph, let's say, where you had a bunch of like data points, something like those are supposed to be points. And then you do like a line of best fit sometimes too, right? Where it'll be something like that. That's different, right? You can see how a broken line graph is like you just play connect the dots. It's kind of the easiest one, I'd say. All right, so that's pretty much what a broken line graph is. I'm gonna let you guys go through the example there. Let's just go into the next one, the build your skills, and let's just kind of go through this together. So it says the following graph shows Tom spending on lunch for the past week. Okay, so we've got money going up the side, amount spent, right? And then on the bottom here, we've got Monday to Sunday. So how much did he spend on lunch on Wednesday, and then how much did he spend on Friday? So really, it's just reading this thing straight up, right? So Wednesday, we know the dot is right there. So how much did he spend? All you have to do is, well, if I drew a line straight up from Wednesday, and then a line straight over to there, that's where that dot lines up, right? So we just gotta be able to read the side. So it goes up by like that is $5, that's $10. So every one of these ticks must just be $1. So it looks like he spent $3, right? Because there's one, two, three is where that was at. So on Wednesday was $3. On Friday, he spent, well, Friday, it's still on zero right now, right? So he spent $0. So on Friday, $0. All right. On what day did he spend the most on lunch and how much was it? Give one possible reason why he might have spent so much that day. Okay, so what day did he spend the most on lunch? Really, it's the highest dot is all it is, right? So this dot up here is the highest. And let's make sure I know where that's at. It looks like he spent almost 19. You can see this dot's not quite on $19, so it's like 18.70 or something like that. You can't quite see, but we'll call it $18.70. Give one reason why he might have spent so much that day. So that's really going to be up to you, that one. But really, it could be anything, right? So, like, don't overthink this one. On Sunday, maybe he went somewhere different, right? Somewhere where, like, meals ended up costing quite a bit, like $18.70. That'd be quite an expensive meal. So maybe he went to, I don't know, not the keg, that wouldn't do it, but somewhere more expensive than, McDonald's or something like that. Okay. Number two, use the graph provided to answer the following questions. So now we've got another one. Up the left side, we've got heart rate. On the bottom, we've got time, and it's by time of day. So it's like goes AM to PM type of thing. So this graph too, you can see that there's little numbers over top of them. That actually just makes things easier. All that number is what it is going up the side. So 120, that means that's 120 beats per minute. It's just telling you what that is right on the graph, which is kind of nice. So, what does the graph show? So, I'm actually going to let you guys try to figure that one out. I'm going to leave a little box that you can type in there. So, just looking at this graph, what is it actually telling you? How would you sum that up, right? And don't just say Katie's heart rate. It's going to be Katie's heart rate, um, dot, dot, dot. There's going to be more to it than that. Okay. When was Katie's heart rate the lowest and what was it? So, again, I'm going to let you guys figure that one out. So that's for part B. And then C, when was her heart rate the highest? What might or why might this have been so? So again, I'm going to let you guys give me a possible solution to that. There could be more than one answer to questions like that, right? All right, move on to the next one. Okay, the graph below shows the value of a particular stock that Vince bought over a 10-week period. If week one is when Vince bought the stock, use the graph to answer the following questions. All right, so for those of you that don't know what stock is, that's you invest in something. Let's say like you invest in some business, right? Let's say some business that's starting up or something like that. So that's the value of that business at that time, right? So um, yeah, hopefully that makes sense. If you buy a bunch of stock, then let's say you bought it at a certain price that it is down there. That stock might go up depending on how well the business does. So all of a sudden, if you bought it for $3 at that point, now at this point up here, 4 weeks later, that stock is now worth a lot more, right? It's worth over $12. So that's what I mean by stock. So it's a way of like investing in stuff. Anyway, so at what price did Vince buy the stock? So one thing you need to be careful about here though is you can see that this is $3 right there, right? So I can't just like count every one of these ticks and assume like I can't go, okay, there's one tick, there's two, there's three. He bought for $3. I can't do that because $3 is up here. So what we have to do is a little bit of math. Um, what I would do is go, okay, well, this is at $3, and there are one, two, three, four, five ticks. If you go 3 divided by 5, that would tell you what every one of these ticks would be. So, okay, so if we went 3, right, 3 divided by 5, that's equal to 0.6. So what that's telling us is that every one of these ticks is 0.6. So if you want to just make sure that you get this right, what I would do is go 0.6 and then plus 0.6, which is 1.2. So now I know the next tick is going to be at 1.2 and then plus 0.6 again. So that one right there is going to be at 1.8. So what price did Vince, or at what price did Vince buy the stock? $1.8. All right. When was the stock worth the most? If Vince had sold it then, what would have been his profit? Okay, so the most, we're just really looking for like the biggest point, right? So remember when you're trying to figure out what that number is, if we want to get a good kind of estimate on that, remember each one of these ticks we said is 0.6. So let's figure out what the first tick is there. So that first tick would just be, well, 12. Oh, I'm going to zoom in a little bit here. 12.06. Okay, so if that's what that point would be right to there, then this point right here, it'd probably be, it looks like it's like, I don't know, a third of the way up maybe. So this would probably be 12.02. There's a bit of guessing going on there, but that's what we'll say, 12.02, $12.02. Okay, so that's what the stock was worth at the most. $12.02. Okay, and then what would have been his profit? Well, that's just going to be the difference between what he started at and what he has now, right? So that'd be his profit. That's what he'd end up making. So if I just go 12.02 and subtract 1.8, so we'll go 12.2 minus 1.8. And when I say 1.8, I should have went 1.80, right? Because it's $1.80. That makes more sense to think about it that way. Okay, so 12.02 minus 1.80. His profit would have been $10.22. Okay, moving on to the next one. So again, I'll let you guys look through these examples. They just kind of show this being done too. But I'm going to skip on to the next one just for the sake of time more than anything. All right. So this one says, Canadian Review magazine is published once a week. The Canadian company keeps track of the number of magazines sold from different outlets to determine the market trend. The market trend is just like how it goes up and down. The following data show the number of Canadian Review sales at a local store over the past 8 weeks. Okay, so we've got some data here. Draw a broken line graph to display the data. Are sales magazine increasing or decreasing? So the whole reason we do graphs is because looking at this table of numbers we have up here, it's kind of hard to really tell if things are going well or going bad. It's a lot easier on the graph. So what we're going to do is make a graph. And actually, if you wanted to, you can do it in your book the same way I am. I would make these lines though with a ruler. So just make sure that these are straight at this point. Okay. So now broken line graph. Um, Usually or not even usually, the number that goes up consistently, like this number like of weeks goes up 1, 2, 3, 4, 5, 6, 7, 8. That's going to be the number that we want to have on the bottom. Okay, so we're going to have weeks on the bottom. So I'm going to write, and you need to label it too. So I'm going to write weeks. Okay, and then we'll go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's my weeks along the bottom. And then going up the top, it goes from 20 up to 28. So if you can, you usually want to start on this side. So number of copies sold here. Let's write that down too. So number of copies sold is what's going to be going up the left side here, up the y-axis. So then what we want to do, you don't usually want to start at 20. We could almost start right at 20 and do that. But that's not typically the way we like to do it. Usually, if you can, you want to make that 0. So 0 is going to be our bottom. And then go up by normal increments. So 0, 10, 20, and then 30. Okay, and then we got to be a little bit, guess a little bit because we don't have actual graph paper on this one. But at week 1, just go straight up from week 1, and week 1 is right at 20. So that's going to be our first dot right there. Week 2, 22, so a little bit higher, something like that. Week 3, 18, so like a little bit lower than where we started. Week 4, 15. You know what, I think I made 18 a little bit too low. 18 be something like that. 15 be right in the middle between 10 and 20. 5 is going to be at 30, so a big jump up. 6 is going to be at 26, so a little bit lower. 7, 32, so even higher. Okay, and then 8 at 28, so something like that. Okay, so the broken line graph part of it now. You would just really connect the dots. So from there to there. And you guys should use a ruler too, since you already have one. It's a little tougher on my computer to do that, but... Okay, so now from that, we can kind of see the trend. So going on down, oh, actually, sorry, it says, are sales of the magazine increasing or decreasing? So over time, it's easier this way to see now that they're increasing, right? We kind of had a bit of a dip there for a bit, but more or less the trend is that it's going up, right? You can kind of see if you were able to draw a line, going up, it would be something like that, right? It's on the increase. All right. Okay, next one here. Let's make another graph. Oh, that's not it. 1 minute. There we go. Okay, so again on this one, what I do on the bottom is I'd make age across the bottom because it's the one going up the same every time. So age. And then brackets, we write weeks is kind of the unit that we're using. So I'll let you guys do that once we get it figured out here. And then weight would go up the left side. So weight in kilograms. All right, and then just make sure that you go up by the right units up the left side. So really, this one probably should be easier than the last one because I would just go up to 5, right? Or just even over. So, just 1, 2, 3, 4, 5, and then just make sure your points are where they need to be on there. So I'm going to let you guys go ahead and finish that graph for me. Okay, 6. A long distance truck driver records the distance he drove each day for 2 weeks. All right, so again, um, you're going to have to make another graph of that. This one's a bit, well, it's not really that much tougher. I'd even do the same thing. I'd go up to like 600 maybe across the top because your biggest number is 560. So it's going to look really similar to the one you just did. So go ahead and do that again and then answer these questions. So graph the data, and then are there any data points that seem unusual that might have caused them? Do you think this graph is a good representation of the data? Okay, new skill here now. We're going to be talking about 2 different vocab. We've got interpolate and extrapolate. So what we mean by that is, well, interpolate. So the first word there, right, that one. What that means, if I looked at this graph down here and I said, okay, looking at this graph, let's say if I asked you what was so this is growth of a bean plant is what we're looking at. So we've got, weeks across the bottom and then height across the left side. And I said, okay, what do you think the height of this plant would be after 4 weeks? Well, all I would do is start at 4 and I'd draw like, a line going up to where it is. And I'd be like, well, I don't know. That looks like it'd probably be like, well, that's 25. So 22, be 22 centimeters. That's interpolating. That's what you're doing is you're figuring out what a dot would be in between the points. Okay, and then extrapolate. Um, you can think about the word like extrapolate as being like extra. It's kind of like what happens after. So let's say if I asked you, what do you think the height of the bean plant would be at 12 weeks? Well, kind of like drawing it up after this graph ends, it looks like it'd still be somewhere there. It looks like it's starting to level off and this plant is like done growing. So if I was extrapolating this graph after 12 weeks, I'd say that it was probably at like 38 centimeters, right? So interpolate means like figuring out in between the points. Extrapolate means like the extra points if you were to make more points on the end. Um, and then just using the graph to figure out what you think it would probably be. All right, so let's do some. Okay, so number 7 here says Therese, I think that's how you say the name, is on a road trip and is keeping track for car's fuel consumption. The graph below shows the amount of gas in Therese's car at different times of the day. Use the graph to discuss what she might have been doing during the different time frames. Okay, so we've got the time of day across the bottom. We've got the volume of gas in the tank, right? Um, so yeah, what do you kind of think might have happened at different points here? So I'm going to pop up some questions here, and I would like you guys just to fill in the boxes as they come up. Give you a little hint on this one though. So at that point, the car was almost empty, right? Well, maybe we kind of think it was getting low. What might have happened at this point where all of a sudden we've got more fuel in the tank? Maybe I'm giving away too much. Okay, so going on down. Okay, 8. Lumber is often priced in board feet. A board foot is a piece of lumber 1 foot long by 1 foot wide by 1 inch thick. The graph below represents the cost per board foot of Kiln-Dried spruce over a period of 1 year. Okay, so first thing, you didn't really need all these like 1 foot, 1 foot, 1 inch thing. We're just worried about like one kiln or whatever that might be, uh, and the cost of it. So we've got this graph kind of showing the cost of this particular board over the different months. So what is a general trend in cost of kiln dried spruce? Okay, so for A, I would say the general trend, if you could like draw a line kind of, from where we started, it's generally, it looks like a downward trend. So it does seem like it's most expensive in March, or like, it's really most expensive in June, I guess. But then, just pretty systematically starts to go down throughout the year there. So we just say a downward trend. Okay, B. The graph does not show the cost in August. Use the graph to interpolate the cost of kiln-dried spruce that month. So we're looking for the price in August. So we'll let you guys actually go ahead and tell me what you think the price would be there. Okay, C. Based on the general trend in the data, what would you estimate the cost of kiln-dried spruce to be the following month, March? So that's extrapolate. Right? Instead of interpolate, we're figuring out what would it be the following month, like after February. So right here, pretty much, we're saying in March. What do you think it would be? So I'll let you guys go ahead and give me a number, a reasonable number that you think it would be there. All right. So again, I'll let you guys kind of look through this one for um, maybe help you out with some of the questions in the next one too. But I'm going to move on. Okay, so a new skill here now is pretty much just drawing two graphs on the same graph is all it is. So you can tell this time we've got 3 bits of data. We've got the month that's going to be going. That's going to be across the bottom like it has been all the other ones. But then we've got male and female. So here, I'll just kind of read the question for you here, though. So it says Rachel is an agent for a cell phone company. The data below indicates the number of cell phones sold to males and females in the last year. All right. So I'll give you a hand to start on this one. You're really just going to have the month across the bottom. So just a tick for every one of the months there. So January, February, March, April. And you're going to want to write them all down. So January, February, yada, yada, yada. And then up the left side, what we're going to need is these numbers. So those numbers that are in here, right? So it starts pretty low number, like 21, right? And it goes all the way up to, it looks like the biggest number we've got is 442. Is that right? Yeah. So I need this graph to start at 0 and go up to probably like 500. So what I would probably do is make 5 ticks. So 100, 200, 300, 400, 500. And then we're going to be plotting these things across. So what you're going to have in the end here, I'm not going to do the whole thing for you, is what I would do is make one color for males and one color for females. So if I made, well, I just even start here. So let's say male, the first number was 53 in January. So that would be, something like that, right? Females, let's make orange maybe, would have been at 21, so like down there. So you're going to have two graphs just graphed on the same thing. So maybe I'll do one more. So February, females were 222. So 200 was a second tick. So something like that maybe. Um, Males were 150. So something like that. Okay, so you can kind of see what's going to happen though. I've already kind of got like 2 lines kind of started here. That one, and then that's the female line. So that's pretty much it. But just do all of the points. So I've kind of started off, give you the first few points, but I do want to make sure that you guys label your axes. So go ahead. So make sure you do that, and then connect your dots, kind of like we had here. Okay, when you're done that, here's your questions. So B, write a statement describing the general trend in cell phone purchases over the year. Does the graph indicate any relationship between the number of cell phones purchased by males compared to females? Why or why not? Do you think this graph is a useful representation of the data? If so, why? If not, what might be a better way to show trends in cell phone purchases? All right. So when you guys are done that, Let's move on. So 14. Okay. So, oh, page 14. Sorry, it's number 10. Sorry, it's just page 14 on my list, not on the actual thing. Page 71. All right, number 10. I'll actually let you guys skip this one. So let's cross that one out and just say omit on it. All right. 15, new skill. Okay, the last skill we're gonna do here now is dealing with graphs that might that kind of manipulate or make the data look worse or better than it is sometimes. And this is something that happens in um, on the media all the time, like with on the news and stuff, where they'll show a graph and everybody like, "Oh my God, it's so terrible." But then when you kind of like look at it, you're like, "Oh, that's not near as bad as I thought." If you actually understand how to read the graph. So here's an example of that. So let's say we've got a graph like this. Notice there's a little squiggly line down in the bottom there. That little squiggly line means that it's starting, like we're making the graph look like it's starting at 500, right? They've skipped everything below it, and then they're going up by 50 every time here. So 50, 50, 50, right? So we can kind of look at the cost of sheet metal by the year and look at these huge up and downs, right? Like it looks like the cost goes like all the way down and then all the way up and then all the way down. Like it looks like it's all over the place, right? um and that's really just because of the way we've made the graph, right? So if we look to the next page here, this is as if the graph were from zero. So 0, 150, 300, 400, 600, 750. Now it doesn't look near as up and down, right? Because you can see that it's actually less of an increase and a decrease. It's just kind of dealing with, up in this range instead of like the whole graph being up and down. So that's one way that a graph could be misleading, right? So that's pretty much it. So let's just do this one together. It says consider the graph below uh, of Marcia's weekly grocery expenditures. So amount spent, and then again notice there's this little broken line thing down here. So it just automatically starts at like 1950, right? It doesn't show all the way down to zero. So that can be misleading, right? So it says, what does it represent? So this shows her spending over the different weeks, right? So apparently she was only spending, like 1975 on groceries in week 1, and in week 6 she's spending like $24 on groceries. And look at this huge graph how it goes from all the way from the bottom and then all the way up there again, right? So as it represents her spending every week would be a good answer there. What is the general trend in Marcia's weekly grocery expenditures? So the general trend, I would say, if I was just gonna like draw a line, it looks like it's going up. Looks like it's definitely going up over time, right? What is misleading about the graph? So pretty much what we were saying before, it looks like it's just a huge amount, right? We've got, it goes all the way from 1975 to all the way up to there, right? But if you drew that on a graph that started at zero, you can see that the difference between $24 and 1975 is only $4. It's not huge. It's not like, this looks like she like started off by spending like almost nothing to spending like a huge amount. So that's how it's misleading, right? So draw a graph that better represents her expenditures. So the way you would do that is just draw the same graph, but you're going to have this axis is going to go all the way down to start at zero. That's all you would do. Yeah. And if you want, I'll let you guys can skip that too. I just want you to know that that's what you would do. Okay, page 75. Let's let's just talk about this one. Um, so we've got percent of Alberta population in two different graphs, right? The difference between these two graphs is that this graph over here just has more years in between. It has more data points. This one has less. So A says, which graph makes it appear that the decrease in rural population was more rapid? Why? Well, that's going to be this graph because it looks like look at this one. Look, it goes from here in 1941, and then all of a sudden down here, it's like a steep, like all of a sudden just drops. That looks more rapid, but it's just because there's a whole bunch of years in between there. There's 20 years between 1941 and 1961. This one, 1941 to 1961, you can see that it kind of like curves or kind of banks down and just more gradually goes down. So B, which graph do you think is a better representation of the actual change in rural population? Probably the one with more data points, so probably this one. Use the graph to interpolate what percentage of population was rural in 1916. Okay, so 1916 isn't on either of our graphs, right? So 1916, it'd be like in between these ones. So I would say that point would be right about there. So like 61 or 62, something like that. If we went to this graph, it's a little bit tougher to see though, eh? Because this one, you would say, okay, 1960s or 16's about, there. It's gonna be higher. It's like almost like 70 at that point. So this graph is going to be more accurate if we want to interpolate anything. Use the graph to extrapolate what percentage of the population will be rural in 2011. Okay, so this one, 2011, would be, like over here. And it looks on this graph like it's flattening out, so it's probably almost going to be the same, so 20 or 19 or something like that. But this one looks like it was starting to go downward, right? So if I was to extrapolate that graph, I'd probably put it even a little bit lower because it looks like it was like on a downward trend over there. So it'd be like, 17 or 18 instead of 19 up there. Okay. All right, practice your new skills. So this is going to be you guys now. That's just everything that we've talked about so far. I'm just going to read these and then I'm going to let you type into the boxes what the answer is. Okay, so Reba has joined a 13-week walking group. The graph below indicates her total steps per week. Use the graph to answer the following questions. So go ahead, take a look at the graph for a minute. All right, A, approximately how many steps did Reba walk the first week? And then how many did she walk the last week? All right, B, during that week or weeks, did she take, oh wow, sorry. During what weeks did she take the lowest number of steps? About how many steps did she take? Is there a general trend in the number of steps she walked per week? If so, what's that general trend? So I'm going to leave that up to you guys too. So, yeah. Okay, moving on. The data below indicates the approximate area of forest burned in forest fires in Canada each year from 1999 to 2009. Display the data on a broken line graph and discuss any trends you see in the graph. Okay, so take a look at that, and then what you're going to need to do is make a table, or not a table, sorry, a graph. Something like that. Use a ruler again, like I said. You can use graph paper too. I have some of the at the back of the class there. Yeah, so go ahead and make a graph of that, and then discuss any trends you see in the graph. So whether it's going up or down, or slowly up or slowly down, or whatever you kind of think on that one. Okay, 3. The graph below shows the average house price in Vancouver in 2009 by month. Describe the trend in house prices in Vancouver during the year. During what months were the prices the highest? Okay, moving on to the next one. Use the multiple broken line graph provided to answer the following questions. So we got a bunch of different stuff here. We got brand A, brand B, brand C. You can see up the side we've got numbers sold, whatever that might be that we're selling. Yeah. Part A says, what is the general trend for sales of each brand of t-shirt? Okay, B says, if you were to keep only 2 of the brands for sale, which 2 would you keep and why? Okay, last page. Okay, so each month the librarian does inventory to determine the number of different titles of different genres that are available in the library. Okay, so we got a few. It's going to be a similar type of graph as the last page there. Something going to look something similar to this, right? Be easier if you get 3 different colors of pen or something like that. Um, okay, so use the data to draw a multiple line graph showing the number of science fiction, historical fiction, and love stories available each month over an 8-month period. Explain any trends you see in the data. What might a drop in the number of titles available mean? Okay, and that's it. So we're going to move on to 2.2 in the next one. One thing I want to make sure you guys are doing, especially in this though, is before you move on to the next one, I need you to come and show me your graphs because I can't get you guys to do the graphs in that ed puzzle. So I'd like you to, before moving on to any of the new one, just kind of flip through. I want to see how the drawing of the graphs part of it went. Okay, other than that, that's going to be it for that video.